I hope everyone's doing well. Thank you for joining me. I'm Mr. Rish. We're solving this second order non-homogeneous or inhomogeneous differential equation. You see it, y double prime plus 25y is equal to 5x squared plus x. The function is not equal to 0. It is equal to something other than 0, a quadratic expression. You know what you have over here, something which looks like d squared y or dx squared plus 25y is equal to a certain function. If that certain function was equal to 0, you'd be looking at a homogeneous, but this certain function is equal to a quadratic expression, therefore it's non-homogeneous, and therefore you have to solve it in a technique that you are familiar with from the previous video. You have a certain general solution that is made up of a complementary function plus a particular integral. We have to determine both of these, then marry up the answers to get our general solution. You're going to look here at the left hand side to determine your complementary function. You're going to look at the right hand side to determine your particular integral. We will start with the complementary function determination, and you have to remember all that you've learned with regards to the homogeneous. Remember, with the homogeneous differential equations, you could have two real solutions. You can have one real solution because they're identical, and then you can have complex solutions, which are complex conjugate solutions of the form a plus and minus bi, and then each of these have their varied answer presentations. All of that has to be remembered. Keep it in mind as we're looking through this question. We're looking at the left hand side right here, and you know y is equal to e to the power of rx. Therefore we're looking at a first order derivative, which is r e to the rx, and a second order derivative, which is r squared e to the rx. When I plug it in here, I have r squared e to the rx plus 25 e to the rx. This thing is not seen in this expression, so we don't use it, and you equal it to 0. We're determining here the complementary function, so you treat what you see here on the left hand side as a homogeneous differential equation. Isolate the e to the rx, and then I have an r squared plus 25 is equal to 0. When you push this on the other side, it zeroes out, so I'm just removing it. R squared plus 25 is equal to 0. R squared is equal to minus 25, and then r is equal to plus and minus 5i. But you can present this better as a plus and minus bi in the form 0 plus and minus 5i. Why am I doing that? Because you have to remember the template for something like this is e to the power of ax parentheses a cosine bx plus b sine bx. These capital A and B's represent two constants because we're looking here at a second order differential equation. When you solve it, you should have two constants. The A and the B's over here represent the values which are coming from right over here. The A and the B, the lowercase a and b. And we will bring that in for you in terms of our answer right over here. You don't need to see this because you know this stuff, and I'm erasing it. Our complementary function over here, which I can better yet just post for you right over here. My complementary function is going to be y is equal to e to the power of, now look right over here, e to the power of 0x, because here a plus and minus bi is 0 plus minus 5i. This is equal to 1, so you don't even have to bring it in, it's meaningless. You can skip this part altogether and just focus right over here, because again we have 0 plus and minus 5i. We are looking here at a cosine 5x plus b sine 5x, where these capital A and B's represent our constants, and this right here is my complementary function, and it has been determined. Now we have to determine our particular integral. Keep in mind, you have to remember everything you've learned with regards to solving homogeneous. Again, you can have two real solutions, you can have one real solution, or you can have two complex solutions, and all of that you have to remember, and the varieties of presentations differ based on what you have. Now let's look at the particular integral. For that, we focus on the right hand side. Our form here is of the cx squared plus dx plus e, and this here equals y. We're focusing here on the particular integral determination. When I'm looking here at a second order derivative, I have to go through the zero order first and the second order. So the first order derivative of this is a 2cx plus d. The second order derivative is 2c. These items get substituted into your equation. Even though you're not seeing a first order derivative here, you're still solving for c, d, and e. You're still looking for your quadratic, your linear, and your constant items. And let's do it. My second order derivative here is a 2c plus 25y, which is this. 25 times cx squared plus dx plus e is equal to 5x squared plus x. Open this up. I have a 2c plus 25 cx squared plus 25 dx plus 25e is equal to 5x squared plus x, and I'm bringing in a 0. I have a quadratic, a linear, and a constant term. That's 0. Don't forget it. Look at your quadratic terms. We'll solve these one by one. The values of c, d, and e. My quadratic components are the ones with the x squares. I have a 25 cx squared is equal to 5x squared. The x squares can cancel out. I have c is equal to 5 over 25, which is equal to 1 over 5. c is equal to 1 over 5. Now let's focus on the linear terms, or the ones with the x. I have a 25 dx is equal to x. The x can cancel out. You'll have a 1. Take the x on the other side. X over x is equal to a 1. So d here is equal to 1 divided by 25, and we'll save that. D is equal to 1 over 25. Let's lastly look for the constant term. Look at our constant terms, the ones without any variables. I have a 2c plus 25e is equal to 0. I know what c is. It's 1 over 5. So I have a 2 over 5 plus 25e is equal to 0. Solve for e. You push this on the other side, it becomes a minus 2 over 5. Divide this by 25. I have a minus 2 over 125. It's nothing than algebra. Push this on the other side, push this on the other side, and you'll have a minus 2 over 125. E is equal to minus 2 divided by 125. We have over here a complementary function. I want to present my particular integral for you all before I present the general solution. What is a template for my particular integral? Exactly what the function is. It's equal to a quadratic, so we're presenting it here in this quadratic format. My particular integral is going to be y is equal to, in this format, I have a x squared over 5 because it's a 1 over 5 plus x over 25 minus 2 over 125. If you want to bring everything in a common denominator, you can, and it's nothing wrong. I have a 25 x squared plus 5x minus 2, and you can push the 1 over 125 outside. I'll have here a 25x squared plus 5x minus 2. This in its entirety right here is my particular integral. Y is equal to all of that. Let's present our general solution, and we are done with this question. Everything has been erased except for what you need for your final answer. My general solution is equal to your complementary function plus your particular integral. What is that? Y is equal to my this, which is right here. Remember again, e to the ax was affecting cosine bx plus sine bx. My solutions were 0 plus and minus 5i. This was a and b. When you put this a value right here, it made all of this go away because it was equal to 1. You were left only with this part, which is exactly why you see only that part. So let's put it right here. It was equal to a cosine 5x plus b sine 5x plus my particular integral, which is all of this, plus 1 over 125. And you don't have to do this common denominator. You could have kept everything separate, c, d, and e, in the cx squared plus dx plus e format. But by putting it in this way, it looks a little better. You have here a parentheses 25x squared plus 5x minus 2, and here is our entire solution. Everything I'm putting here in the box is your solution. Thank you for watching. Have a good day.